Alright, so in this video, I just want to talk about vectors. So vectors are it's very important that you actually come to understanding vectors in physics. Vectors is a math subject and a physics subject, essentially. Right, so vectors. In many terms, you just describe vectors as arrows, right? It's something with a size. It might have a size of 5 units, and it's got a direction, right? You can say relative to the x-axis, it's at an angle of theta, right? So this arrow here, it's got a magnitude and a direction. Vectors can be arrows that show a magnitude and direction, right? So this is one way of interpreting vectors with arrows like this, okay? The other thing, the other way that you can interpret arrows is with a matrix, essentially. This is, you call this essentially a matrix. With a matrix where the x position is described by the first number, and then the y position is described by the other number, right? So you can have this arrow isn't a vector. I'm just like drawing the arrow. So you can have it. So for example, you can have 3, 5, right? And then this vector in the shape of an arrow would look like 1, 2, 3, 3 in the x direction, 1, 2, 3, 4, 5, and 5 upwards. So this vector would look like this, okay? Like this. And we can call this vector B with a hat on top of it, right? Now there's 3 types of vectors that you need to understand. So number 1, the first type of vector we have is, so we have 3 types of vectors. Uh, these are position vectors, direction vectors, and unit vectors. Okay, it's these 3. So let's discuss position vectors first. Let's say you have a grid. Let's say you have a grid like this, okay? You have a grid, you got the y-axis, and then you've got the x-axis, right? The point right in the middle, this point, is called the origin, right? And then let me draw another point on here, right over here, right over here, right? Let's just say the coordinates of this point is 3, 8, okay? 3, 8. Now, the position vector of this point, the position vector of this point goes from the origin, so 0, 0, it goes from 0, 0 to the coordinates of the points. Which will be essentially 8, 3. X-axis always comes first. So the position vector of this point is going to look something like this, okay? And we can call this, if this is point A, the position vector of this point will be A dash. You always write vectors with a dash. So position vector dash, you can call it B, but if it's a vector, it's a dash. You can call it C, but if it's a vector, you say C dash. If it's whatever name, if it's W, then that vector will have a dash on top, okay? So you just put a dash over it to say that I'm describing a vector with this quantity. So you can say A dash is equal to, and then you can write it in this form, which is going to be 8, 3, okay? And that's the position vector for you. A position vector always goes, a position vector always goes from the origin to the point, to a certain point in space. Okay, so that's a position vector for you. Next, I'm going to discuss the direction vector. So same again this time. So let's say I have a grid again, just like this. So I've got the y-axis and the x-axis. Okay, this time a direction vector can be something like from this point to this point like this. Okay, so in this case, a direction vector describes the direction that a vector is kind of facing. It's basically, before, with the position vector, it was pinned to the origin. Okay, in the direction vector, it's not pinned to the origin. So for example, it could be floating in space like this, and let's say from here, let's say from the tail to the head of the vector, it goes 3, 5, okay? So this vector, we'll call it B dash, okay? Direction vector. So B dash is equal to 3, 5, okay? Now, if I place this B dash from here and I place it over here, okay? These two are the same. Okay, B dash is the same anywhere in space. So I can place B dash over here. I can place B dash over here. I can place B dash anywhere I essentially like. So B dash is the direction vector. Okay, I hope that makes sense. I hope you understand that a position vector always goes from the origin to the point, and a direction vector is a vector with a size and magnitude, but essentially it's not connected to the origin. It's not connected to the origin, right? These are all the same, b dash, b dash, okay? That's what a position vector, a direction vector is. Now, a unit vector, let's say I have another thing like this. A unit vector is a vector like this, right? Let's say this is A dash, okay? No, sorry. Let's say this is B dash. This is the B dash direction vector, okay? Which was equal to, if we remember correctly, it was 3, 5. Okay, so we have 3 going upwards, we have 5. So B dash is equal to 3, 5. Okay, so this is what B dash is equal to. Now, a unit vector is a vector with a magnitude of 1. A unit vector is a vector with a magnitude of 1. So how do you find the unit vector? So all vectors have a unit vector. Okay, So, for example, let's find the unit vector for B. So the unit vector for B is, first you find the magnitude, and also a unit vector you always place a hat, like a up arrow like this on top of it, to say it's a unit vector. So the unit vector for B will be equal to, yeah, so the unit vector of B will be equal to, well, the way you find the unit vector is, first you have to calculate the magnitude here. So you have to calculate the length of the vector. So calculate length. Basically, you have to make this vector smaller so that its magnitude is just 1. You have to make it so that its magnitude is just 1. So its magnitude is 1, but its direction stays the same as B, right? So how do we do that? So what you have to do is find the magnitude of the vector first. So for example, it will be, you use Pythagoras' theorem. So it'll be 3 squared plus 5 squared equals, I'm just going to say m for magnitude, squared, right? So you just square root all of it. Square root 3 squared plus 5 squared equals m. That's the magnitude of the vector. Okay. And then what you have to do is, you have to do b dash divided by the magnitude, right? And when you divide it by the magnitude, it just becomes 1 over m multiplied by 3 over 5. Okay. Okay, because b, and then this will just be equal to 3 over m and then 5 over m. Okay, and this is equal to the unit vector, which is equal to, one second, let me just draw that. So the unit vector b hat, the unit vector, is equal to 3 over m, 5 over m. Okay, so this vector b, let's draw that. So it will be a fraction of the length in that direction, like this. And then when you do when you do and then when you do 3 over m squared plus 5 over m squared, it will basically just give you 1, because that's what the magnitude will be. Okay, so I hope you understand what the unit vector is, the direction vector is, and what the other vector is. Ultimately, you can put down that b is equal to m, its magnitude, multiplied by b dash, like this, right? So the big vector is equal to m multiplied by b dash, by b with a hat. Right, thank you for watching this video on unit vectors.